Chapter 9, question 46. A sequence starts -3, then 1, then 5, then 9. If you wanted to find the 50th term of the sequence, would an explicit equation or a recursive equation be more useful? Well, obviously this is going to require that we understand the difference between an explicit and a recursive definition. If you remember, the recursive definition says, hey, the next one is going to do something with the one that you're currently at. So if I wanted to think about the recursive definition of this particular function, let me zoom in a whole bunch on this function. Oh, that's as big as I can get. If I wanted to think about the recursive version, it would be, okay, I'm at a particular value. The next value, right? So let's say that I'm at the value, and I can't remember the notation that we used for this. Let's say that I'm at n. I'm at the value n. Let's see, for recursive functions we used, I can't remember if we used a's. I think we use a's. So let's say this. I'm going to say, okay, the next one. Let's say a n plus 1. So how this notation is read is the next value in my sequence is equal to the current value in my sequence plus something. Now I kind of jumped here, but I was looking at this earlier and I could see that these values were all increasing by 4 units, right? So if I take 1 minus -3, that's a jump of plus 4. When I go from 1 to 5, that's a jump of plus 4. And when I go from 5 to 9, that's also a jump of plus 4. So this function keeps increasing by 4 units. And the recursive rule looks like this. It says the next one is the current one plus 4 more, how much it goes up by. So the recursive formula it's useful, right? It tells me how to get the next one if I know the current one. The problem is, in order to know what the 50th term is, I would need to know what the 49th term is. And in order to know the 49th term, I'd have to know the 48th term. And in order to know the 48th term, I'd have to know the 47th term. So in order to find every single term along the sequence, I need to know the one, before it. So that's kind of problematic, especially when you're going all the way up to the 50th. So I think in this case that if you wanted to know the first 50th term, I think that our choice would be, I would want to know the explicit formula. This formula says, hey, you just basically plug in a number and it'll tell you what that term is. Now, in order to get that, right, we need this to be in first term form, meaning that this is counted as the first term, right? This is the first term, and then the 1 is the second term, and the 5 is the third term, and the 9 would be the fourth term. I can easily write this using like the function rule, but it's not going to be in first term form, so we're going to have to translate it over. So let's go ahead and write just the rule for it, right? The rule is, let's just say that it's a function, right? Y's are equal to, we're going up by 4 each time, so I'm going to say 4x and then minus 3. So what I'm saying is when x is 0, this rule produces the number -3, right? When x is 0, it produces -3. If x is equal to 1, it produces the number 1, right? 4 minus 3 is 1. When x is 5, it produces, when x is 3, 12 minus, when x is 2, 8 minus 3 is 5. So here's my problem, right? These are the term numbers, right? The first term, second term, third term. But the values I have are x is 0, right? X is 1, x is 2, and x is 3. So if we refer back to problem 89 and we want to write this in first term form, it looks like this. It looks like, and I think they used function notation. So the nth term, the value of the nth term is, and then we would just make this one change 4 times, and instead of writing x, we're going to say n minus 1 and then minus 3. So if you look at it, the only thing that's different here is before we were just writing an x. Now we've replaced that x with n minus 1. And it's a very subtle, small change, but that's the only thing that's different between them, other than the fact I'm using function notation instead of y equals. But what's nice about that is now when I take this n minus 1 and I put in the first term, right? In other words, when I put a value of 1 in here wanting the first term, this whole thing then becomes the number 0. And when this becomes the number 0, what I have is 4 times 0, which is 0, minus 3 is negative 3. So by me putting in n as 1, right, n equals 1, I get the value that I'm supposed to. I get the value of negative 3. So what we're looking at right now is first term form. And again, what's super nice about this is if I want to know the 50th term, I just say, hey, the value of this sequence for the 50th term is equal to 4 times 50 minus 1, and then minus 3 from that. So if I grab my calculator, I'm looking at 50 minus 1 is, of course, 49. I'm going to multiply that by 4, and then just subtract the number 3 from that. So I get that the 50th term should be 193. Definitely other ways that we can get this, but I think that's probably the best way. And then let's see, part D says, write the explicit equation for this given sequence in first term form. Okay, so let's first of all try and figure out what's going on here. It looks like I have decreased by a certain amount. In fact, looking at all the subsequent terms, it looks like each time I am subtracting 1/3, right? It looks like if I subtract 1/3 from 3, I would get 2/3. So this goes to by minusing 1/3. And if I have 2 2/3 and I subtract 1/3, again, right, 2/3 minus 1/3 is that. And then if I subtract 1/3 again, right, so I can see each time I'm decreasing by 1/3, and I'm starting out, in the equation form, I'm starting out at 0. So if I was to write this as an equation, it would be y is equal to, let's see, I'm decreasing by 1/3 each time, so I've got negative 1/3 x, and then I'm going to add 3 to it. So this is telling me, if x equals 0, then I get 3 out of that, and that totally works. And again, focus in on the part B, and you can see the one little change I'm going to make is instead of writing just an x here, when I switch this over to function notation, I'm going to replace that with n minus 1. So this becomes the following. It becomes, in function notation, right, it's equal to, oops, I've got disappearing writing here. In function notation, this becomes negative 1/3 times the quantity of n minus 1, and then plus 3. So this is equivalent. This is the first term form for this rule. And if I want to know any term in this sequence, right, if I want to know what the first term is, if I plug in a 1 to this, it will give me the number positive 3. And you can see that happens because when I plug a 1 into it, right, that clearly becomes negative 1/3 times 0. If I plug a 2 into it, this becomes 2 minus 1, this becomes a 1, so I've got a single negative 1/3, and 3 minus a 1/3 is indeed 2 2/3.